Good evening. I'm Suraj, software engineer at Grafana Labs, and today we'll talk about distributed tracing, what it is, Grafana Tempo, what it is, how we built it, and why we built it, and we'll also talk about the storage layout and the query language that we built to query traces. And I'll also answer the question why another query language. So raise your hand if you're familiar with distributed tracing. Okay. I see some hands. Okay. Raise your hand if you use used tracing. Like day to day, sometimes. Okay. I see. Raise your hand if you run a tracing database like Jaeger, Zepkin. Oh, I see. See, that's my crowd. Anyone using Tempo here? Raise your hand. I want to see. Okay. Yeah, you all come and give me some feedback at the end. Yeah. So I wanted to see how many folks are familiar with distributed tracing. So let's do a quick rundown on what is distributed tracing. So trace, it looks something like this. You see different color bars. We'll talk about what they are. So the core unit of a trace is a span. You can think of a span as an event or an operation that happened. In other words, you can say span is the log line equivalent of tracing. So something happened, you generate a span out of it, similar to how you log in a log line. And another important thing to keep in mind in tracing is context propagation. Because tracing is all about continuing a transaction across service boundaries, and context propagation is how you do it. So when a request comes to you, if it doesn't have an existing context, you basically generate a new trace. You create some spans, you attach those spans to that trace, and then you pass that context down to the services that you're calling downstairs. And you do that via context propagation. It is mostly done via headers. In HTTP services, in gRPC also, you attach parameters to pass that context information downstream. And then the service will take that context information and continue your trace, generate its own span, and add those spans to that same trace. And then you see something like that. So here you see multiple colors, right? So here you see like each color indicates a different service, and the time moves from left to right. So we can see here that the operation D happened after C, and E happened after D, and we see that B and C are happening parallelly, and similarly the operation D and B had some overlap, even though the D started later. So another question is, why do we need tracing? Like I already have logs, metrics. Is that not enough? One thing that you cannot do is you cannot build that ordering information across services with log lines. You have to do timestamp correlation, or either you'll end up logging request IDs, which is what I call poor man's tracing with logs. So might as well just do tracing. So again, like modern services are complex. Your user might request something that take a different path depending on what they requested across services. In same service also, you would have different code paths, right? So it helps you understand what path your requests are taking. Again, the temporal information is hard to build with just logs and metrics. So that's where the tracing is useful. And you can see the end-to-end transaction from the first service to the last service. Again, I'm assuming all of your services are instrumented. So another thing that you can think of tracing as, we all have a call graph, right? Like we all know what a call graph is. You have functions are calling different functions. You can think of tracing as a call graph. but for your distributed services, and that's where the word distributed and distributed tracing comes from. Okay, so now I've convinced all of you to do tracing. How do you do it actually? So there are 4 steps. First one is instrumentation. So you need to instrument your application to generate these spans and traces and continue that context with context propagation and send that context to the downstream services that you're calling. Open telemetry is the most popular way to instrument services these days, but there is Jaeger and Zipkin SDK also that you can use. In many languages, you don't have to manually instrument. So languages like Java, you load a jar and then it is automatically instrumentation. The auto instrumentation generates some sensible defaults for you. But in some languages that is not possible, so there you have to instrument it yourself. Now that you have instrumented your services are generating those spans. So you need a place for, because your services are different, right? Like service A, B, C, they're running in different places. You need a place to collect all that data. That's where the collector or tracing pipeline comes in. You can use OTel collector or any other collector to collect traces from all of your services. And another important thing that you do at collector level is you make sampling decisions, you make data modifications and enrichments. So stuff like attaching cluster labels, region labels, you know, what is the sampling rate that you used, you do that. Removing PIIs, you do at collector level. Then your collector will basically take all the traces, batch them, and send to a tracing backend. In this picture, you can see Zipkin, Jaeger, Tempo are shown. Any of them can take your traces and then store them. Okay, now that you have stored them, you need a way to, you know, query it. So again, that's the 4th step in the pipeline. So you instrument, collect, store, query. And Tempo fits in the step 3. It is a tracing storage system. And we'll talk about that later in the details. So here is an example tracing pipeline that looks like. So here you see service 1, service 2, service 3. All these services are generating traces. And then the dotted line is your network boundary. And you run, in this example, I'm showing a Grafana agent running in your infrastructure, collecting traces from all. And then it is writing to tracing backend. And then you're using Grafana to query it. So this is an example of a distributed tracing setup that you'll see. Okay, that was introduction to tracing, what it is, how to do it. Now we'll go deep into Tempo and why we built it. So first I want to talk about how Tempo works. So Tempo relies heavily on object store to save its traces for long term. So we will receive your trace, build a block, cut that block, and we'll flush that block to an object store for long-term storage. That allows us to store traces for cheap. And when you query, we pull that block back from object store, do the querying, and then return the results back to you. And we'll talk about object store later. And because we rely on object store, we can offer longer retentions for cheap with Tempo. So okay, let's see how we can run Tempo. You can run it as a single binary, like you don't have to make it complicated. Just one Go binary, you start it, and that binary does everything, your ingestion and querying, compaction, everything. So just one S3 compatible or an object store bucket with the binary, and you have a tracing setup ready. Another way you can do it when you grow big is you can keep that bucket same, and then you can deploy individual services, or you can deploy a read path as a single service, the write path as a single service, and scale your reads, writes independently. You know, there are many ways to run Tempo. It is very flexible. You you can pick and choose what you want to run together or what you want to isolate out. Uh, so one way is you can use Tempo open source. You can instrument your application agent like Grafana agent or any other hotel collector, store Tempo and Grafana, and now this is your tracing setup. If you have enterprise needs, you can use Grafana Enterprise, but for majority of the folks, open source Tempo is more than enough. And if you don't want to run it, you can just get fully managed service from Grafana. Okay. Another thing that a lot of people ask is that tracing is hard, like at scale. Scaling tracing means throwing a lot of money at it. So I wanted to share some numbers from one of our biggest clusters that we are doing. So we're doing around 1 petabyte a month in this cluster with 30-day retention with replication factor of 3. And a lot of people have complained that the search becomes sluggish when they have a lot of data. And I just looked over average and P90 and P99 for a day for that cluster, and these are the latency numbers that I saw. I could be unlucky, and that was the slow day for the querying, but yeah, these are the numbers that I have from one of our biggest clusters. So we are using Tempo at this scale. So if you have up to a petabyte of traces a month, you don't have to think about if it scales or not. Now let's talk about TraceQL. One question that everybody asks that why do you need another query language? There was an interesting blog post that came out in 2018. It had a very interesting title that says, I don't want to learn your garbage query language. And the author says that every vendor in the whole world is making their own query language. Just give me some SQL. And it resonated with people. You can see that the orange site interacted with it, had a lot of comments and upvotes and all. So I'm going to convince you that why TraceQL is a good idea. One thing that no other query language allows us to do is query the structure of a trace. So trace is inherently a tree-like structure, right? We saw a tree where one service was calling a bunch of other services, right? So when you have a query language that is dedicated to query traces, you can do a lot of stuff. Because you can always assume the tree structure, right? And you can ask interesting questions that you will not be able to ask easily with existing query languages. And that's why we thought it is worth building a query language just to query traces. One example is, like how many connections to the database my slowest request making. And you have to find the slowest request, and then you have to track down database connection. Another one is, show me all the queries that took more than 10 seconds and did more than 3 SQL queries. You're not interested in single query that is taking more than 10 seconds. You're interested in the whole transaction that there were 3 queries and they took more than 10 seconds. So TraceQL is centered around operating on spans. Like I said, span is a log line equivalent of tracing world. Similar to how you search log lines, with TraceQL you operate on spans. So the questions that you ask at span level. And a trace is just a collection of spans. It just has an ID that ties all the spans together along with the timing information, right? So you can ask that, give me a span with name foo and duration more than 5 seconds. Like you can say, give me all the requests where response was 200 and they were in API v1 path. Like here we're doing a regular expression. Another thing that TraceQL has that we wouldn't have been able to do with any other query language is type awareness, right? So you can say it knows the status code is an integer, so you can do greater than, less than, equal to on status code attributes, right? Again, it is aware of duration, so you can say 10 seconds, 100 milliseconds, 1 second, and you can again do greater than less than operations because it understands that duration is the time, and I can do time comparison. Regular expressions, again, I mean, you can do it easily with it. Another thing that we have built is aggregates. So you can say, this is my query, these are the span results, and then you can run aggregate function on it. So you can say count 1. So what this will give you, this will give you all the traces where DB name is set to Postgres, and only more than one spans are there, right? This is an interesting query. You can just say count is equal to 1, and you will find all the spans where only all the traces where only single span was there, which is an interesting query because it allows you to find all the single span traces. Because single span trace is pretty useless, it doesn't convey anything. It is as good as a log line. And when your instrumentation is broken, you might produce single span traces, which would have been harder to hunt down. But with TraceQL, it is just one query. Again, you can ask. It understands time, so you can say average of duration. It knows the duration is time. It can do average. Then you can do a comparison on it. Another interesting query is you see this query, right? Like this query is asking a question that says, show me all the spans with 5xx or higher, where path contains API, and request is either post or put. And the average duration of these spans should be more than 1 second. So you are doing Boolean operations on these conditionals, and then getting the result, and then you're doing a time condition on it. And you're saying, I'm not interested in like max min, just give me the average more than 1 second, right? Which would have been a difficult question to write if we were using something like SQL here. Yeah. Another thing is pipelining here. In this query, we have used pipeline. So we wrote this query, we piped it into average. You can do again count, and then aggregates. So this is recently merged 1 week ago. So you can do a by. So you can say query my spans, and then you can aggregate them by your attributes, namespace, service name, whatever you want to do. You can do min-max on these attributes because it understands start is the start time of the span, end is the end of the span, right? So you can do, I'm only interested in end minus start greater than 10 second, right? And then one thing that we are also planning to build is structural operators in TraceQL. So you can ask that, okay, give me all the spans. Like you are traversing the tree here actually with these operators. They are not yet implemented. So I'll have an example once they're implemented. But yeah, another one is select. So you're interested in only subset of the columns, and you can say, okay, do this query, return me all these columns. I want to look at them with the select operator. And you don't have to memorize all these things. Grafana has a built-in query autocomplete for this. So yeah. If you want to learn TraceQL, I would say like there is an hour-long session on TraceQL and what kind of things you can do with TraceQL. I would recommend go and watching that session. Okay, so now I said we'll come back to object store, right? How is this possible with object store? And one thing that I haven't mentioned was with Tempo 2.0, we moved our backend format to use Parquet. Parquet is an open hybrid storage format. So we will try to answer that question here, right? So TraceQL requires very high cardinality. You can throw any labels on your traces. There is no limitation. Here you are querying large subset of columns. So your trace will have 10, 15 attributes, but at a time you are only interested in 2, 3. So you don't care about the whole trace, you only care about the subset of the columns. So having a columnar nature helps. Another is you're also querying a row only operation. When you say something like status code is equal to 500, you're only interested in values of that, right? So you're querying column wise, you're querying row wise, and our goal was we want to do it with only object store because object store allows us to scale tempo without enormous costs. So we'll talk about logical and physical storage layout, right? So this is a table. You can see there are rows and columns. So physically, you can store it row-wise, where you store each row after another row, or you can store columnar-wise, where you store full column and then the next column, and like here you see A, B, C are stored sequentially, right? And then there is a hybrid storage format where you basically take a subset of the rows, you call it a row group, you store that row group, and then you have another row group, right? So here you see here row 1, 2, 3 is row group 1, so you store that in columnar fashion, and then the second row group comes. So this is the hybrid storage layout. So in row-wise, if you want to do row-level queries, it is really efficient, right? So you can ask, say, give me row 2. You can continuously read that row. You see that red continuous chunk of data. But it is problematic when you say, okay, give me column A. You have to go all over the physical storage to get those values, which again adds up and becomes cumbersome. If you do columnar only, then you can easily answer the question that says, give me column A. You can sequentially read and get that column out. But it is hard to query for the row. Because again, you have to go all over the physical storage, right? So hybrid basically finds a middle ground in that. And in hybrid, you see that, okay, subset of the rows are stored in row groups. So it is, I feel like, a middle ground between columnar and, because in a row group, you can do column only scans, you can fetch those columns, and then you can do row level queries. You don't have to read the whole thing. So another thing is, okay, that's nice, but what else can I do with my tracing data? You can attach your tracing information with your metrics, and you can log your trace ID within log lines, and then you can jump, like you're searching your logs, and then you can directly jump to a trace. From a trace, you can jump to a log if you can do correlation. Another thing that a trace allows you to do, right? We said it's a tree, right? Here we see a tree. So when you look at a trace, so instead of looking it in a sequential manner, you can also look it as a tree. Another is you can query that tree. So we call it service graph. And you can query it in the form of a tree instead of writing a TraceQL. Another thing that Tempo has is called metrics generator. So your spans have information about operations, right? Tempo can take those spans and generate Prometheus metrics out of those spans and push them to any Prometheus compatible storage. And then that gives you metrics from your traces. So even when your application is not instrumented for metrics, you get some metrics out of it. Obviously, it's not as good as hand instrumented application that knows about all of your metrics, but it is something. Right? Another, like this is an example of span metrics. So you can do basic red metrics from span metrics. Requests, errors, duration, and stuff like that. And from those red metrics, you can build dashboards and then highlight your slow endpoints, slow queries, and then directly jump into TraceQL. Right? Because you're generating these metrics from traces, you have common attributes between your metrics and traces. And now we have a demo. So the demo is available on GitHub, but we'll do a live demo right now. So I just cloned that repository, and I'm running Docker Compose up. Okay, and what it is doing is it is starting Grafana, Tempo, Prometheus, and 3-4 fake services that will randomly fail, so that we have some failures, and then there is a database involved, or at least database queries are involved. Then there is fake request or fake server, and there is, I think, a message queue also thrown in there. So yeah. So the demo is running. Let's see. Let's go load the Grafana. Okay. I have a dashboard, and I can. Okay. Just give me last 5 minutes, and you can see all these metrics are generated from the traces that are generated by the hotel instrumentation in these fake services. So you can see your request rate, and these are your different services. The names are pretty mythical. The mythical is the theme that we are going with in this demo. And you can see the error percentage by target. And then you can directly jump from here to a TraceQL query. So you're saying, show me all the requests to this target with HTTP status code 200. Now I can say, okay, show me duration more than, okay, I see 512 milliseconds. We'll do greater than 100 milliseconds, right? Ooh, something is funky. Yeah, so you see all the requests in the spans that we got back. Duration is more than 100 milliseconds, right? Like this spans is 111 milliseconds, and this is the duration of the total trace. So I can directly click here and jump to a span. And then I can see, okay, this is my span, and then I can directly jump from here to the log line. Yeah, I guess it's not visible. Is it visible? Okay, cool. Yeah, so let me close this so you see this. So here you have a log query directly built from traces, and then how we jumped from metrics to trace. And from here we can again go back to a trace. I said, okay, this is interesting. I'll directly jump to a trace. And here you have your full trace. And okay, you don't like this view, you can look at it as a node graph. And so here you see, I clearly see that, okay, something went here. No. So in mythical recorder, something is going on, right? And you see, like, this is taking 1.35 seconds, right? Another view that I talked about was service graph view. So you can just say, okay, last 5 minutes, give me a service graph. So you get a graph with endpoints, and then you can just say, okay, I see some red here. Give me the rate of failed requests directly from your traces. So here you are able to directly jump to a query that shows you the graph of error rate. Now you're saying, okay, I don't care about failed rate, just give me total request rate. So yeah, so this is the service graph view. Another thing that we want to show is exemplars. So exemplars are something that you attach to your metrics. Think of it as an extra attribute. Thank you, folks. If you want to play around with this demo, you can go to that repository, clone it locally, and then do Docker compose up. And that's all.